Good morning, good afternoon, good evening. Nowadays, in the IT industry, as a part of digital transformation, every company is working and adopting recent cutting edge technology like AI, ML, IoT, cloud, virtual reality, and microservice based architectures, and many more. And companies are doing innovation around it. From small to enterprise business, every application is generating a small or large amount of data, storing that data, doing analytics, and doing predictions and taking future decisions on the given data. We are living in such a technological era where we have everything on our fingertips, and it is needed to have those all the applications to be available and accessible 24 by 7 into 365 days. And due to this, it is an important thing that companies should deliver business to mitigate customers' requirements. This is the reason data which is stored into database and on the storage devices need to be available, reliable, scalable, protected, and cost effective as well. As we know, entire data is stored into different kinds of databases, which is heard of the IT infrastructure. And I'm going to talk about mission critical databases on premises and databases on the cloud. Let me introduce myself. I'm Amol Bhoite and I'm working as a senior technical lead in Zorin Software Solutions, Pune, India. My role is to execute and deliver customer solutions with storage, data protection, virtualization, databases, cloud, doing the product integrations, performance data analytics, and working with converged and virtualization platform to increase company growth and revenue. In my experience, I handle 1000 plus production databases including SQL, NoSQL, data warehousing databases including on-premises and cloud databases. As cloud world is growing, during the entire journey, there was always a question by the senior management as well as by the application architect. What if new database will deploy on the cloud? Or what if we migrate on-premises databases to the cloud? And always put on discussion topic if there are production issues in the environment. I have seen there are multiple aspects and consequences to the databases on premises or on the cloud. And I think this is one of the important topic where people should aware of, and that is the reason I have selected this topic for the presentation. Let's move on to agenda. In this presentation, I will go through different terminologies, databases on-premises versus cloud considerations. Then I will talk on database migration between on-premises and cloud. Then I will talk on customer case studies and conclude on the presentation. This section explains different terminologies with respect to databases. If anybody know or hear the word production database or production application, or important database or critical database, those all are pointing to mission critical databases. Then what exactly is mission critical database? It is an essential part to run business and applications, and database should be available at any time of the day, demanding applications around the clock and 24 by 7 into 365 days availability. It is required for survival of business operations or organization or which are serving to demanding applications like banking, finance, ERP, CRM, business intelligence, trading, data warehousing, and analytics. There are different choices of scalable databases dependent on nature of an application. Developer databases are used by few users and are typically used by the development team for test, development, UAT purposes and should be okay if there is database downtime. Small business applications are accessed by the less users. For as an example, application deployed in universities, schools, government offices need to be available during specific time. This can also accept database downtime after office hours. Medium businesses host applications which need to be available all the time. However, those can also accept once a while downtime. Example is paying credit card bills application. This can go down for some time in a year for few hours for security patching or upgrade purpose. Enterprise applications, for example, banking application, online gaming application, those need to be available for all the time and cannot accept downtime. And this is what we are going to talk about on premises versus cloud databases. Databases can be deployed on premises data center or in private cloud or in public cloud. In on-premises data center, your data is stored in the local data center and the company is responsible for management and maintenance of the data center. In the private cloud hosting, also known as an internal cloud, resides on company's intranet or hosted data center where all your data is protected behind a firewall. This can be a great option for companies who already have expensive data centers because they can use their current infrastructure. However, the main drawback people see with the private cloud is that all management, maintenance, and updating of data centers is the responsibility of the company. In the public cloud, your data is stored in the provider data center, and the provider is responsible for the management and maintenance of the data center. This type of cloud environment is appealing to many companies because it reduces lead times in testing and developing new products. As we know, mission critical databases has variety of data, which has complexity, and as business changes, velocity of the data also changes and increases as well. An application grows, quantity of the database. In the graph mentioned, there was not much growth of the data till 2018. However, starting 2019, application generated data drastically. In such cases, any company has to prepare their infrastructure such that there should be a business continuity. And company infrastructure won't prepare for such changes, there is possibility of database down, loss of data, which results into penalty. As company maintaining the database, they have contracts and liable to keep databases up and running. This will impact large-scale customers as well as multiple applications depending on each other. There will be a traffic draft, service availability. Majorly, it will affect database performance drastically, which is not acceptable at all for business applications, and it will create a panic situation across the team. In a nutshell, I would say mission critical databases outages impacts revenue and profitability and trust of an organization. This slide talks about comparison of available databases from the different cloud providers, that is Amazon Web Service, Microsoft Azure, and Google Cloud Platform, and on-premise data center databases. If you see, there are different databases types available, including relational, NoSQL, in-memory, document-based, column-based, etc. And every cloud database provides data migration service that helps you migrate databases to any of the cloud provider quickly and securely. Among the other cloud providers, AWS has multiple database service offerings. While choosing any of the database cloud service, I recommend to go through the required service documentation, their offerings, their restrictions like size of the disk supported, number of maximum IOPS, and cost along with it. Let's see what are consideration one has to look into while choosing databases on premises versus cloud. That includes reliability and availability, scalability, manageability, control and compliance, security, and the last important topic is cost and performance. First consideration is reliability and availability. Critical databases need to be available for entire year and should not tolerate database downtime. So customer has to provision a solution such that even for any kind of database upgrade or patching, database should not go down and should be accessible all over the time. In general, you may heard term database RPO or database RTO that is applicable for database reliability. RPO means recovery point objective where database cannot lose a single transaction. For example, in the banking application, we cannot lose a single entry. RTO means recovery time objective where the criteria is in how much amount of time you will bring the database up and running. For mission critical databases, if we don't have zero RPO or zero RTO, then it would generate a loss for the company. For database to be available and reliable and achieve zero RPO and zero RTO, here is the on-premise solution. This is the solution which I worked on and it is used by multiple enterprise customers in different domains. This is Hitachi Vantara solution for a database. If you click on the link, this is the reference architecture for Oracle Real Application Cluster using Hitachi Global Active Device, that is GAD, using Hitachi Ops Center Protector. GAD delivers non-stop operations such as synchronous data replication and ensures superior disaster recovery for distances up to 500 kilometers. Hitachi Ops Center Protector is modern data protection solution to simplify the creation and management of policy-based and copy data management workflows. In this solution, if you look at the high-level infrastructure, there are two sites, Site 1 and Site 2. There is third site as quorum site for maintaining the replication heartbeat mechanism. On Site 1 and Site 2, per site there is VSP G900 storage which provides enterprise reliability. Two redundant brokered G620 fiber channel switches are there. Two Hitachi Advanced DS220 servers using processor from Cascade Lake family. There are two redundant Cisco Nexus switches for internal service communication and one management network switch available. Hitachi GAD is used for block level replication between two storages using replication link. Here Oracle database is replicated between two storages synchronously. In the storage architecture, you can see on both the sides there are 16 parity groups using solid state drives with RAID 10 configuration, and RAID 1 is mirroring and RAID 0 is striping. On the storage side, storage dynamic provisioning pool is used to create virtual volumes for operating system and database storage. On the server side, native multipathing is configured for performance reasons. Oracle cluster is configured on the 4 Hitachi servers. In this solution, if there is storage failure or server failure, or any storage port failure, other site or port will take care to serve database requests. Customer can also bring down server or storage for maintenance, patching, upgrade, or any other purpose. In a nutshell, this architecture provides database reliability and availability for entire year. AWS provides similar high availability and reliability solution using multiple availability zone replication using Oracle Data Guard. Here, Oracle Data Guard, VPC, EC2 VMs, public and private subnets, bastion hosts, and NAT gateways are configured in the autoscaling group. AWS provides a secure infrastructure to run your Oracle database on enterprise level architecture, including high availability. If we compare on-premises and AWS cloud solution, both are providing availability, reliability, database protection, fault tolerance, and failover mechanism. Only on-premise solution using GAD provides the two-way replication between two storages. Let's talk about database scalability. Database can be scaled in and scaled out based on the database nature and implementation. A distributed database is a database that consists of two or more files located in different sites, either on the same network or on entirely different networks. For scale out, we can add multiple nodes as and when needed in distributed database. Non-distributed database is a database that consists of files located in single site. For scaling, we can add resources as and when needed in non-distributed database. In terms of on-premises versus cloud comparison with respect to scalability, on-premises has limitation and implementation challenges to scale due to limited resources like storage and networking. In cloud, there is always automated scaling to add or remove resources to maintain database performance. I'll give you one example. As I was working with one of the European customers in the e-commerce domain, having their own data center, and they were having heavy workload during weekends and festival season. For that, we needed to work on weekend to manage the database workloads. However, due to limited compute and network resources, We were facing a lot of performance issues and did not figure out a solid solution. So we tried to look for cloud solutions when we run workloads with AWS EC2 with auto-scaling groups. We were able to manage entire workload during weekends and festival seasons. And afterwards, we migrated our entire application and database to AWS. In terms of database scalability, I'm not suggesting to go always for cloud database. However, first take a look at the business and predict database growth for next 5 years. Try to follow top-down approach while scaling the resources. Database manageability is one of the important aspects while considering database deployment. For on-premises, self-service is not available. Automation can be possible using automation tools like Ansible and Terraform. However, those automation needs additional development as well as management by the internal team. There are multiple management and orchestration license tools available in the market. However, those need to be managed explicitly and need product knowledge to manage those. So there are manual tasks which are time consuming and resource dependent from the on-premise side. On the other side, cloud provides manageability using cloud database as a service, controls the database management and monitors the backups, restores, and using the APIs provided, user can integrate it to existing automation framework. Cloud Database as a Service also provides database performance and real-time monitoring, diagnostic and root causing analysis, trend analysis, and capacity planning. If customer has different and multiple databases, then cloud is better in terms of manageability. Next is database control and compliance. It is one of the crucial aspects due to the data location. Database control refers to the task of enforcing regulations so as to provide correct data to authentic users and applications of the database. In order that correct data is available to users, all data should conform to the integrity constraint defined in the database. There are many industry and governmental regulations driving the need to improve data protection, management, administration, governance, policies, etc. For database administrators, adhering to database compliance requirements is a critical part. It needs to ensure that production deployments and test database are protected from breaches and unwanted changes, saving time, money, and reputation. The message that comes through loud and clear is that compliance is an important thing. There are different questions generally asked as a part of database compliance. What information is stored on the system? Where is the information stored? Who can access the system? What they can access, and is the data access appropriate? For the database on the on-premises, one can answer all the questions easily, but on the cloud side, there is compliance challenge and there is always a question on the compliance side. Below are the database compliances. First one is GDPR database compliance. It is General Data Protection Regulation. Is a European Union law on data protection and privacy for all individuals in the European Union. Next one is SOX, which sets requirements and regulates how companies operating in the US report and disclose finances in order to improve the reliability and accuracy of financial disclosure and subsequently reduce fraud. HIPAA database compliant is Health Insurance Portability and Accountability Act, establishes policy and procedures for safeguarding the privacy and security of an individual. GLB Act is also known as the Financial Modernization Act, which controls the ways that financial institutions deal with the private information of individuals. The last one is PCI DDS database compliance, that is the Payment Card Industry and Data Security Standard, which is an information security standard for organizations that handle credit card designed to reduce credit card fraud. To effectively and efficiently meet data and database security regulation requirements, organization needs automated tools that can guarantee compliance. I worked with one of the customer in healthcare domain, and when we had a discussion on one of the POC that time, they clearly mentioned that they do not have plan to deploy or migrate their databases on the cloud, at least for next 5 years. Due to the rules and regulations, issues in the company. So it is mandatory for such customers to keep their data on premises data center. In the early time, customers were reluctant with the cloud due to the compliance issues. Nowadays, public cloud providers are strictly implementing compliances, and due to that, customers have compliance concerns are slowly moving towards the cloud. However, many customers in BFSI or healthcare industry, customers still wanted to go with on-premises. Database security and compliance go hand in hand with infrastructure and human resources. The database security assessment checklist can be your go-to list for ensuring your data is protected. With database encryption, an encryption algorithm transforms your data within a database from a readable state into a ciphertext of unreadable characters. With the key generated by the algorithm, a user can decrypt the data and retrieve the usable information as needed. Database auditing involves observing a database so as to aware of actions of the database users. Database administrators and consultants often set up auditing for security purposes. Also, incorporating updates into your website maintenance routine is an easy way to improve your database security. According to the Forbes study, by 2020, 57% of customers has adopted a hybrid cloud solution. 75% of the customers are thinking security as the biggest challenge for cloud adaptation. 60% customers are thinking that privacy regulation governance issues in the cloud adaptation, and 49% customers are delaying cloud deployment due to the cybersecurity skills gap within their organization. Then the question is, in terms of security, on-premises or cloud is better? Security, compliance, and protection of your data go hand in hand with infrastructure and human resources. Having a robust database protection policy is the key and starts from very initial phase of any setup. You need to have trained storage system and database admin resources who are also well versed in database compliance requirements to know how to protect database. Once you know the challenge involved with database protection, it is helpful to explore tools that provide single window self-service software. Tools can also migrate your private data centers to the cloud and seamlessly operate hybrid cloud architectures that take advantages of both storage formats. The short answer is that based on what priorities you have, either type of security could be a good fit for your business. Let's move on to last database consideration, that is cost and performance. I work with multiple databases in different environments with many customers, that too with different domains, where cost and performance is the key aspect when application response time come into picture. Many a times while there are production issues, I always heard let's increase system resources including CPU or memory. Purge the old data, tune the SQL PL/SQL procedures. However, to drill down the issues, I always follow top-down approach to resolve the performance issues. In fact, building the infrastructure, technical team must focus on storage, networking, server, operating system level, as well as at the database architecture level to avoid possible database performance issues. If we look at the overall level, at the storage side, SSDs, NVMe, disk performance values need to be evaluated. On the network side, network has to be configured to meet its network speed. On the server side, CPU and memory resources should be appropriate to handle the application requests. Redundant dual port host bus adapters and network cards need to be configured. On the operating system, application need to be configured to meet its standard best practices, and multipathing has to be configured for better performance. At the database side, data files has to be equally distributed on the storage to have parallel read and write operations on all the storage devices. Also, based on the available memory, database memory parameter has to be tuned as per the best practices. If anyone can follow such practices, future possible performance issues can be avoided and debugged easily. So when we get new infrastructure resources like storage, network, servers, those need to be benchmarked to see if we get expected performance result. For an example, let's say a storage vendor says,
Our storage system with NVMe drives delivers X number of random and sequential results. Customer needs to first evaluate if they are really getting X performance result with their infrastructure. And if they are not getting that performance result, then they have to look into tuning network, server, or on the storage side. There are different open source storage network server benchmarking tools available in the market. This is Oracle Composable Platform solution with Hitachi VSP E990 storage and Hitachi Advanced Server DS220. In this solution, we have used 8 parity groups with RAID 10 configuration. We have used NVMe drives. Oracle cluster is deployed on 2 servers and 16 terabyte database size is created on the storage. We have executed storage and database performance test cases on the current environment. For the storage performance, we used Orion tool where we executed random read, random write, sequential read and sequential write test cases. For the database performance benchmarking, we have created database of 16 terabytes of size and using PeakMarks license product, we executed random read, sequential read, full table scan and database writer test cases with and without storage level encryption. Customers whose application needed to have such performance results, those customers can opt for this on-premises solution. Or if they want to look for similar performance on the cloud, then customer can open cloud cost calculator, provide server and storage disk details, then provide provision IOPS details on the calculator and get the costing for the particular configuration. There is an option for short as well as long time duration database to reside on the cloud. Also, this cost varies for the partial payment as well as the upfront payment. There are different types of payment available on the cloud. Move on to database migrations. If customers are having concerns on mission critical database to run on premises or to run database on the cloud, then customer has an option to migrate those from on-prem to cloud or cloud to on-prem. At the high level, customer can follow the following steps. First, customer can assess the database environment, then check the security settings, then check if internal team is capable of really doing this, then select the right migration tool and do the POC and test the applications. If everything looks good, then customer can migrate validated database, keeping the minimal amount of downtime. User can use the cloud data migration service or native tools for the database migration. The database migration service can migrate your data to and from most widely used commercial and open source databases. Based on cloud provider, data migration service supports homogeneous and heterogeneous database migrations. With database migration service, you can continuously replicate your data with high availability and consolidate the databases. Here I'll present two case studies where in the first case study, I'll talk on why customers migrated from on-premises database to cloud. And in the second case study, I'll talk on why customers has migrated their database from cloud to on-premises. In the first case study, customer was in advertisement domain and customer moved their applications on the cloud due to some reason and kept their databases on premises as they were having enough infrastructure resources. But due to the application on the cloud, which were accessing databases from on premises, customers were facing database latency issues and also increased data transfer cost. We provided them a solution to migrate database to AWS EC2 instance using distributed always on availability group with SQL Server 2016. We implemented this solution in two steps that I will show you in the next slide. In the existing on-premises architecture, there was synchronous data transfer happening from primary data center database to secondary data center database. So to move this entire infrastructure from on-premise to the cloud, in the first phase, we created a sync data transfer from on-premises primary data center database to AWS primary database and replicated AWS primary database to secondary AWS availability zone using distributed availability group. In this phase, all the data got replicated to AWS side. In the second phase, we pointed applications to newly created AWS primary database and created distributed availability group between two AWS regions for the redundancy purpose and did database async data transfer to secondary AWS region. This setup created high availability architecture for the database. Due to this solution, there was an improvement in the application response time and reduced data transfer cost. And entire migration happened with less application downtime. In the second case study, customer was in telecom domain and customer moved their multiple databases on the cloud due to some cost benefits which cloud has offered to them. After a year or so, some database sizes grown drastically and they started to face performance issues. And due to some technical incompetencies and not having full control on the cloud services, customer was facing database response time issues. We evaluated the customer issues and provided them a solution to keep critical databases on premises so that they will have complete control on the database resources including storage, network, servers, operating system as well as on the databases. With this solution, customers were able to resolve the database performance issues due to the full control on the hardware resources and as well as prepared for possible near or long-term performance issues. To conclude on this presentation, I have prepared a sample flowchart which any customer can refer and will have overall idea where he should deploy his mission critical databases. However, it may vary as per customer's business problem statement and need. First of all, customer has to look into database control and compliance. And if customer compliance say data should not be exposed to the outside on-premises data center, then customer has only option to go on-premises database deployment. Same applies to the security. On the performance side, if customer gets similar or better performance on the cloud after evaluation or doing the benchmarking on the storage as well as benchmarking on the database, then customer may need to look into the cost aspect as well. If customer is okay with the cost on the cloud, then as we know, cloud provides more reliability, high availability, and scalability. Customers can go with cloud offering solution for mission critical databases. That's all for my presentation. I hope you find it informative. Thank you, my client boss Idor Fritas from Hitachi Vantara and Gargi Singh from Zorin Software Solution for help and support on this topic. If you have any further questions, please let me know. Otherwise, thank you very much and bye bye.